Third type of fluorescent light I want to look at. Essentially, it's a fluorescent tube type form factor. Obviously, it's not a fluorescent tube. I mean, we could squeeze this. It's just plastic. It says it's going to go from 220 to 40 volts, 50 hertz. How much lumens there? 1700 lumens, 6400K. That would be a color. 160 degrees. I guess that's the angle at which light comes out. 140 MA, which would be a current. And yeah, basically whatever bulb is, equivalent 18 watts. So let me have a open of it and see how they did this one. Let's see if it's current limited or if it's just a switch mode like the last one. Too much effort to basically pull this out. It's a strip, looks like a semi-flexible circuit board. You have the circuits there going from one end to the next, and then I guess a negative going on one side. Relatively simple. This in this end where we had the right in, we have what appears to be a switch mode power supply. Just looking from here, it looks pretty much like that. I'll count the number of LEDs and state that. And then if you're watching here, this is the method here. So apparently I was just supposed to push this. It did appear to have glue, but now looking at it, maybe it didn't. There's some silicone, there's something here. But yeah, essentially this little tab, if I had just pressed here, which I didn't quite figure out at the time, and then there's a groove here, as you could see, and that is where this slips in. This is how it looks. Two pins like this. I yanked them out from the back. It wasn't that easy to come out, but yeah, I did. Sort of broken this piece a little. You can clearly see heat shrink, silicone. So let's remove that. Let's have a look. Let's see what they actually put in this. It turns out they've used the same MB10F rectifier here. What they have is a fuse coming in here. So it's fused, you have a filter, and then we have, of course, this bridge rectifier and the two caps. Obviously, we see why this is failed. Those two caps are in fact blown, so that's what the problem is. But the brilliance of this whole thing is this particular chip. This is a buck converter that runs off mains voltage, but this is actually brilliant. It's a current limited buck converter, straight off, no additional components, just a rectifier and this basic circuitry. And this in fact is not a transformer like I initially thought, but when you look, you can really only see two pins fit. This is in fact an inductor. Here's a range. This paper, the data sheet on this is brilliant. It gives a lot of information. This, if you really want to understand how this thing works and the calculation, I'd recommend the data sheet. So let's pull that up now and have a look at some of the finer points of it. As we can see from the data sheet, this is noted as a high precision buck constant current LED driver. It's suitable for 85 volts to 265 volts AC, so practically any normal voltage that you would get in anywhere in the world. It's a 500 volt MOSFET on the incoming, which basically means it can handle any of the ripples that you would normally get. And then the features, if we look at that, critical conduction mode operation, the internal 500 volts, no auxiliary winding needed, and we'll get to that just now. The LED open protection, the short circuit protection, current sensing resistors, and thermal regulation, and it's all in a SOP 8 package, which is brilliant. Applications are for LED candlelight, LED bulb, and other LED lighting, so specifically made for LED. Now if we have a quick look at the typical application schematic, we can see it's pretty much exactly what we see on the board. A rectifier with a smoothing capacitor, a resistor, and another capacitor over that. Then you have the inductor and the diode, and that happens to be the big diode right next to the chip. And then we have the string of LEDs with a capacitor over them. So we see 3 capacitors, and with see 0 capacitors on the circuit we looked at. So this was done pretty much spot on with a typical application. The further brilliant points I want to note is how this thing starts up. Basically, it charges a capacitor uses the Zener to get a 17 volt, and then it basically limits at that point, and it's using that as its power supply. It does not need an auxiliary winding, which is a big savings. You don't have to put additional winding and solder additional contacts onto the board. Also, the paper has a lot of information in terms of selection of the inductors, and basically it can go between 4 microseconds and 240 microseconds. If the inductor is too small, you'll go below that. If it's too large, you'll go above that for the discharge. So that's pretty much the range, and that's what needs to be kept in. Also, interestingly, this thing does not have a fixed frequency. It goes with the voltage. So the lower voltage, it's 5 kilohertz, and it goes up from there. Again, not that you would be able to tell that with an LED light. None of us could see anything close to that. There's of course thermal regulation, as we mentioned before. So all in all, it's a comprehensive chip, definitely fit for purpose. Granted, it's Chinese made. If it is reliable, we don't know, but definitely a brilliant chip. If I had to rate the designs, I would put this one as the best of them all. This chip is really impressive.